Hi everyone, welcome to the HashiConf Europe 2021 application keynote. I'm Yishan, the product manager for Nomad and Waypoint. Speaking with me today is Blake, who's the product manager from Consul. So in today's keynote, we're going to explore the application delivery workflow and talk about the different tools on the infrastructure stack that it encompasses. We'll also get into how this extends into the greater developer experience and talk about the growing importance of getting that right in today's organizations. So to start off, what is a developer experience and why is it so important? Well, when we think about user experience in the world of infrastructure, there are really two types of users. The first type of users are operators. These are individuals or teams that are responsible for selecting, evaluating, installing, and configuring infrastructure tools that match their company's hardware and fulfill business objectives. Once operators settle on a particular infrastructure tool, they take it through a proof of concept phase and then into their company's production environments. Operators generally take on greater responsibilities in taking on the day-to-day management of these infrastructure tools and being responsible for their overall uptime, health, security, and cost. Behind the scenes, operators also play a really pivotal role in educating and onboarding developers and other internal stakeholders at their organizations, teaching them how to use these infrastructure tools when they're needed. Now, the title of the operator has really evolved over the past few years. Historically, we would call an operator something like a system administrator. Nowadays, more common titles for operators are SREs, DevOps leads, or infrastructure leads. Now, the second type of user in the world of infrastructure are developers, specifically software developers. Now, the title and the responsibility of software developers has been largely consistent for the past several decades. The main job of a developer is to write code and ship applications that push the business forward. And so between these two types of users, the operators and the developers, we see that there's a very strong and clear producer-consumer model where developers are the end consumers of the workflows and the infrastructure tools that operators put into place at their organizations. Developers consume and use these tools and follow these workflows to deploy their applications and their software onto their company's hardware. If the developer experience is shaped so much by the operators at any given organization, why does the developer experience matter so much and why are we talking about it today? Well, user experience as a whole has really evolved to become a top priority in the world of infrastructure. When we look at some of the past technologies that once dominated the infrastructure space but have faded away in recent years with their adoption and usage, some examples of that come to mind like Hadoop, Mesos, or Pivotal. These are all examples of technologies that once shared really exciting promise, had a great premise, and boasted some really powerful functionality. However, the user experience for a lot of these technologies, notably in the operator experience side, were difficult. It was a hard thing for an average operator to get started and install and configure properly their own Hadoop, Mesos, or Pivotal cluster. And it's no secret that during the prime years that a lot of these technologies were at their peak in terms of popularity, the proper installation and configuration of these technologies often had to be done by external third-party consultants, professional services, or systems integrators. It was really hard for an average operator to be successful with these technologies out of the box. And as these technologies began to evolve and mature over time, adding more features and functionality, the operator experience itself only got more and more complicated as more features, components, and concepts were introduced into the bucket. And so, as a result, operators had a really tough time being successful with these technologies quickly. And as a result, developers themselves also had an even tougher time being successful using things like Hadoop, Mesos, and Pivotal. And so that really taught the infrastructure space its really first deep lesson around user experience, which is that when operators are not first successful, then developers can't be successful. You have to get the operator experience right before you can go building things for developers. And so nowadays, when you look at HashiCorp and really any other infrastructure company that has really grown in the years since, you see that there is a tremendous amount of collective organic focus that's being placed on the operator experience, making sure that every infrastructure tool that is available nowadays is something that can be easily installed, learned, configured, and managed. Now, HashiCorp in particular has put a really uniquely strong focus on getting that operator experience right. When you look at any HashiCorp product available today, you see that they all share the identical operator-first principles of each tool being a single lightweight binary that's compatible in many environments and flexible enough to accommodate multiple use cases and workflows. And so as a result of this change and evolution, the goalposts have changed. Historically, operators were more concerned with how do I make sure that I know how to install and configure this tool. The vision now has moved towards I now have better infrastructure tools in place that I know have a great installation and day one experience, but my focus now is how do I take these infrastructure tools and put them together into a workflow where my developers can easily learn them, use them, and consume them, and deploy their applications onto my company's infrastructure independently and responsibly. And so nowadays, now that the operator experience is well established in the HashiCorp products, we're putting a lot of renewed emphasis on getting the developer experience right in all of the HashiCorp products. And these three core pillars of utility, efficiency, and ease of use are really how we set the vision as we continue to invest in this into the future. The pillar here to highlight, specifically in the context of application delivery, is really utility. We have a strong belief at HashiCorp that it should be workflows over technologies, and so what that means is that if you're a developer who's working and building on a Java application, we believe that the workflow that you use to deploy your applications and update them should be as simple, straightforward, and easy as it is for developers who are using newer technologies like containers and microservices. With HashiCorp, there's equal consideration and weight given to both the brownfield and the greenfield teams, projects, and workloads. Now that we know where things are set, let's start at the trailhead of the developer experience by focusing on the tool in the stack that serves as the main intersection point between developers and operators in organizations today. And that tool is the orchestrator. The orchestrator is a tool like Nomad or Kubernetes, and the main purpose of an orchestrator is to decouple software and hardware. So before the mainstream popularity of things like Nomad and Kubernetes in the past few years, historically applications were always tied down to a specific server or set of servers. And so as a result, there was really no developer experience or workflow. If you were a developer at your organization and you had to deploy or update your application, your experience was writing in a ticket into your organization. An operator would manually review it, triage it, and make those requested changes by manually going in and making those requests onto the machine. And this is a process that was very manual and could take anywhere from hours to days to weeks, depending on the scale of the company and the size of the requested changes. And the adoption of the orchestrator has really empowered operators to stop thinking about servers as single independent silos and more like dynamic unified fleet of resources that they can pool together. At the same time, with the mainstream adoption of containerization and the public cloud, developers now more than ever can write their applications into lightweight portable formats that can be easily deployed on really any server nowadays with few to no dependencies. And so orchestrators, that adoption of Nomad and Kubernetes we've seen in the past few years, are really the core tool that has inspired organizations to really reimagine their developer experience and workflows from these static, slow, ticket-based models into more dynamic self-service workflows that can potentially have developers being independent and responsible without being exposed to all the underlying details of the infrastructure. And so for organizations, given that the orchestrator plays such a foundational role at this intersection point between the developers and the operators, there's a tremendous amount of emphasis that's been placed on the choice of the orchestrator that you go with. So we continue to see that many large, high-profile organizations opt for Kubernetes for its expansive ecosystem and its powerful first-class support for greenfield projects. And at the same time, a lot of these large enterprises have the budget and staffing and expertise in place to handle the technical complexity of Kubernetes. And there's also a case to be made that there are certain developer segments largely found in large organizations that really enjoy working with Kubernetes. On the other hand, we still see small and medium-sized organizations continue to opt for Nomad for its simplicity and flexibility in deploying containerized and non-containerized applications. The SRE teams and operator teams at these smaller organizations are generally a lot leaner, and they're looking for something that's more immediate, sustainable, and can give them immediate success with their brownfield and their greenfield deployments. And so when we look at the amount of configuration that's possible between Nomad and Kubernetes, we see that these tools at their heart are orchestrators, and they share the same identical universal concept that the application and its details and how it should be deployed should be abstracted into a single job file. In Kubernetes, this job file is written in YAML. In Nomad, this job file is written in HCL. And we see that even between the amount of configuration options available, there is a relative simplicity that Nomad brings to the table when it comes to defining the job spec that Kubernetes doesn't have. But the ultimate reality that we know is that even though Nomad is relatively simpler than Kubernetes, for the average developer that's deploying their application, to take advantage of all these configuration options that are available in either Nomad or Kubernetes, that requires deep expertise, deep context, and exposure to the company's infrastructure. And for the average day-to-day developer that just wants to deploy their applications, they just want the essentials. They want to be able to point to their container image, their application artifact, set their ports, set their resources, and move on. And so even though there is relative simplicity within these two orchestrator tools, the reality is that exposing the raw orchestrator to developers is not really a complete developer experience. And we started to see organizations of all sizes start building these front-end layers in front of their Kubernetes clusters or Nomad clusters to try to expose the right amount of abstraction and craft the right kind of developer experience for their organizations. And so now that we've talked about where the orchestrator is today in the context of the developer experience, I want to pass it off to Blake to talk to us about where the networking and service mesh layer fits into this larger picture.
Thank you, Yishan. Now, I want to switch gears and talk about application communication. What happens once an application is ready to be deployed to production? How does that application communicate with other services in the environment? The challenge often isn't just about enabling application connectivity. Often there are larger concerns that also need to be solved, such as how do you secure and control access to the application, or gradually roll out new versions of the application without affecting existing traffic. Lastly, how does the application deal with network issues like packet loss, delays, or dropped connections? Developers could solve for these concerns directly in the application. However, doing so can have negative or unwanted side effects like increased complexity to the code base, which could lead to longer development times, and also requires networking and security expertise which development teams may not have. So how do you ensure developers aren't impeded by these blockers, but without sacrificing security or developer agility? One way is by using a service mesh like Consul. But a service mesh shouldn't be something that you implement after the deployment. It really should be woven into the orchestration layer. This way, the platform can provide identity-based security and protection of application communication using mutual TLS, as well as observability and resilience for all application traffic. It can also give developers intelligent routing and testing capabilities, allowing for experimental or blue-green deployment strategies. Incorporating service mesh as a core component of the application lifecycle not only creates consistency with deployments, but also gives platform and operations teams a chance to define networking best practices for the entire environment. Having this consistent control plane lets developers follow a common simplified workflow, whether they're interacting with the mesh for things like canary deployments and traffic management, or just deploying with the confidence that their services will be able to communicate immediately and securely. Adding new applications to the service mesh doesn't have to be complex. In fact, applications can easily be configured to utilize service mesh with minimal changes to deployment code. And while a service mesh offers many application-centric features which are beneficial to developers and SREs, a service mesh is not just a tool for developers. It also benefits network operation teams by providing a consistent, higher-level abstraction to manage application communication policies across different clouds and runtime environments, and benefits security teams by giving them the assurance that data in transit is protected and network configurations meet security and compliance requirements. Back over to you, Yishan.
Thank you, Blake. So today we've talked about the developer experience in the context of the orchestrator and then at the networking and service mesh layer. Now we want to talk about the developer experience in a more holistic way and one that spans an entire organization beyond one infrastructure tool or a set of infrastructure tools. Developers today are deploying applications to a multitude of tools. They're generally not restricting themselves to a single orchestrator or a single environment. It's very common for us to find and talk to organizations that are running their core workloads in a Nomad cluster or Kubernetes clusters, but they're also investing and building in new event-driven applications specifically to take advantage of something like AWS Lambda. And so the challenge that we've begun to see here is that as organizations adopt more technologies and adopt these different tools that bring their own UIs and CLIs and configurations, more workflows just naturally emerge. Each tool has its own learning curve, its own requirements, its own visibility concepts, and really requires its own independent workflow. And so over time, as organizations adopt more and more of these technologies, what organizations are also ending up with is many separate divergent workflows and different environments to deploy to, which leads to this overall fragmentation in visibility and decreased developer velocity over time. And so Waypoint, which was really launched last year, seeks to solve this problem by unifying all these different tools together into a single simple workflow of build, deploy, and release. So rather than exposing the full underlying raw details of any given orchestrator or deployment tool, what Waypoint does is it offers a single, standard, and simple abstraction for developers to deploy their applications really into any environment without changing the underlying configuration. So you can take a Waypoint file and you can deploy that application to a Kubernetes cluster, a Nomad cluster, AWS Lambda, Google Cloud Run, all through one single workflow, interface, and abstraction. So of each of the three HashiCorp products that we've talked about today in Consul, Nomad, and Waypoint, all of these products have had new and exciting releases in the past few weeks, with Consul 1.10, Nomad 1.1, and Waypoint 0.4. As folks will see when they dig into these newer releases, you'll see new and exciting features that push these products forward, but you'll also be able to see how these serve as the foundational pieces for us to start building this developer experience that we've talked about so much today moving forward. Thank you everyone for attending this keynote, and have a great rest of your time at HashiConf Europe 2021.